So whether you are prepping for a critical system architecture meeting or, you're just insanely curious about how enterprise AI actually works in the real world, today's deep dive is definitely for you.
Yeah, we're really getting into the weeds today.
We are. Because, look, conversational AI is, it's famous for being creative, right? Like you ask a question, it writes a poem, or it
Sure.
brainstorms a marketing campaign for
Or it
you.
helps you debug some Claude. Yeah.
Exactly. But in an enterprise data pipeline, that creativity is, well, it's a massive liability.
Absolutely.
If you're extracting, say, 50,000 invoices into a downstream SQL database, you don't want a poet. You want absolute, unyielding mathematical precision.
Right, because when you move from unstructured chaos like PDFs, emails, scan receipts into structured systems,
Yeah.
you are crossing a strict boundary.
Hmm.
You're taking probabilistic text generation and forcing it to interface with deterministic databases. And that boundary requires structural integrity. Building that integrity, well, it changes how you interact with the model entirely.
Which brings us to our absolute ground rule for today, our prime directive, if you will.
The exam guide.
Yes. We are strictly following the official Anthropic exam guide, specifically examguide.md, as the definitive syllabus. No deviations. All other materials are just purely complementary.
Right, we are adhering 100% to its official task statements.
So, mission statement for today.
Mm.
We're doing a highly technical architect-level deep dive into what the guide calls Scenario 6, structured data extraction.
It's a great scenario.
It really is. We were looking at the exact mathematics, the schema designs, and the data integrity principles you need to build a bulletproof pipeline.
Because extracting data isn't just about reading text, it's about guaranteeing mathematical and structural integrity. The progression of Scenario 6 essentially maps the journey from a fragile, prompt-based system to a highly reliable pipeline.
Okay, let's unpack this, because before we can analyze any data, we have to capture it without breaking the pipeline, right?
Exactly. You have to eradicate syntax errors first.
Right. And, the first instinct for any developer building an extraction pipeline is usually just to write a really, really descriptive prompt.
Oh, yeah. Please read this invoice carefully.
Exactly. You say, read this invoice and give me the data back in a JSON markdown code block. And, usually that works when you test it.
Usually being the operative word there.
Yeah, because there's a shocking statistic from the sources. Requesting JSON inside markdown code blocks leads to a 2 to 5% failure rate in production.
Which sounds low until you process 50,000 documents a week.
Right.
That translates to thousands of crash pipelines. The issue is that generating raw text, even text formatted as code, leaves room for typographical errors. The model might miss a bracket or, leave a trailing comma.
It's like asking someone to fill out a complex legal contract on a blank napkin. I mean, someone is going to miss a comma, and your downstream parser is just going to crash entirely.
That's a perfect analogy. And the architectural solution, and the exam guide is definitive on this, is tool use combined with a JSON schema.
Right, so you don't ask it to just write out the JSON.
Exactly. You do not ask the model to generate free text JSON in its conversational response. Instead, you define the exact data structure you need as the input parameters of a tool.
So you're giving the AI a rigid form to fill out, rather than asking it to draw the form itself from memory.
Yes. By defining the schema as a tool parameter, the model populates the field structurally. It guarantees syntax-compliant JSON by construction.
By construction.
Right. The structure is no longer just an instruction the model might fail to follow. It's the physical mechanism by which the output is generated. Those 2 to 5% formatting errors, they drop to zero.
Because the API just won't construct the tool call with broken syntax.
Precisely.
But wait, I've seen pipelines where developers set up these tools, they define the JSON schema perfectly, and yet the model still returns conversational text, like 30% of the time.
Yeah, that happens.
It'll just spit out a friendly message saying, here is the data you requested, instead of actually extracting it. Why does it do that if we gave it the tools?
Well, that comes down to how the tool routing is configured, specifically a parameter called tool choice.
Okay.
If you leave it on the default setting, which is auto, you are leaving the decision up to the model.
Ah, so auto is the risky behavior.
Very risky. The model decides whether it should call a tool or just chat with the user. And in about 30% of mixed document cases, the model will just choose to chat. For an automated pipeline, that's unacceptable variance.
So we have to hard code the configuration. We have to force it.
Yeah. And there are two distinct ways to do it, depending on your architecture. If you know exactly what kind of document you are processing, say you know it's a metadata form, you use forced tool selection.
Like formatting it as type.tool, name, extract metadata.
Exactly. You explicitly configure the API call to mandate that your specific tool runs first. It guarantees the sequence.
But what if the pipeline gets random documents? Like an inbox that gets an invoice, a receipt, or maybe a purchase order. You don't know which tool to force because you don't know what the document is yet.
That scenario requires the any configuration.
The any configuration.
Right. Setting the tool choice to any forces the model to call at least one tool from its available list, but it leaves the decision of which tool up to the model based on the document.
Oh, that's smart. So it eliminates the chatty text, but keeps the dynamic selection.
Exactly.
Okay, so we fixed the syntax. The pipeline won't crash from a missing bracket. But here's where it gets really interesting. What if the data itself is a lie?
The illusion of perfection.
Yes, you have what is essentially a perfectly formatted hallucination.
Right, because we have to draw a hard line here between syntax errors and semantic errors.
Because the schema doesn't do math.
Exactly. The schema guarantees the JSON is valid. It does not prevent the model from extracting line items that sum to, say, $80, while populating the stated total amount field with $100.
Because that's what was printed at the top of the page.
Yeah.
So if the schema can't do math, how do we stop the model from just inventing numbers to fill in the blanks?
You have to design robustness directly into the schema. When you make a field required in a JSON schema, you apply immense pressure on the model to provide a value.
Even if it's not there.
Right. If the document genuinely lacks that information, the model's probabilistic nature might lead it to fabricate a value just to satisfy your architectural requirements.
So you're accidentally forcing it to hallucinate.
Yes. So the architectural defense is to design fields as optional or nullable. You explicitly type the field to accept either a string or a null value.
Oh, so it has an escape hatch.
Exactly. It removes the pressure to hallucinate by providing a mathematically legal way to say, I don't know.
Okay, that makes sense for missing data. But what about ambiguous data? Like if you need to classify an expense as travel, meals, or software, but the receipt just says consulting fee.
That's where enums come in. But you don't just use standard enums, you always include an other option, accompanied by a detail string field.
To capture the weird cases.
Right. And furthermore, you should include an unclear enum value.
Wait, unclear. So the model uses unclear to actively flag ambiguity.
Yes, rather than silently corrupting your database with a bad guess.
Yeah.
An honest, unclear categorization is infinitely more valuable than a confident, incorrect one. You can then safely route that specific document to a human.
Okay, but since the schema can't prevent semantic errors like the bad math, the $80 versus $100 thing, we still need a recovery mechanism.
We need an automated self-correction engine, specifically the retry with error feedback loop.
Right, because most developers, they just implement a blind retry. The validation code catches the math error and they just ask the model again.
Which is the wrong pattern. You don't just ask again. You must append 3 specific things to your follow-up prompt.
Okay, what are they?
The original document, the failed extraction, and the specific validation error.
Oh, wow. So you feed its own mistake back to it. You literally say, here's the document, here is your JSON, and your line items sum to $80, but your stated total is $100.
Exactly. With that specific error feedback, the model has the exact context it needs to self-correct. It might realize it missed a $20 shipping fee buried in the footer.
But why go through all that trouble? I mean, why not just bump the retry limit from 3 to 5 and let the AI figure it out eventually?
Because of the hard limits of retry logic, retries are completely useless when the requested data is simply absent from the source document. Using the example from the exam guide, say you have a loan summary. Your schema strictly requires a guarantor address, but the summary just says, refer to Exhibit B for guarantor details.
And Exhibit B isn't in the context window.
Right. No amount of retrying will extract it. Blindly increasing your retry limit just burns API costs. You must programmatically verify data existence in the source before increasing retry limit.
Okay, so now we have accurately extracted and validated the data. We're catching syntax with tools, semantic errors with feedback loops. But in an enterprise environment, we're usually dealing with multi-agent systems, right?
We are.
And we have to synthesize findings from multiple sources. It's like progressive summarization. It reminds me of a game of telephone where crucial details just get lost along the way. So what does this all mean for the final report?
It means we have to talk about information provenance. Summarization inherently destroys what the guide calls claim-to-source mapping.
Claim-to-source mapping.
Right. If your final synthesized report states AI adoption is 45%, but you have no idea which of the 50 source documents it came from, your system can't be audited.
So how do we fix that?
The synthesis agent must be architected to preserve and merge these mappings. Every single claim extracted by a subagent must include the URL, the exact excerpt, and the page number.
So the subagent passes a structured JSON object that carries the evidence with it.
Exactly. But there's a secondary issue. What happens when two credible sources completely contradict each other?
Yeah, what if one source says AI adoption is 45% and another says it's 12%? Does the agent just pick one?
No, and this is the temporal trap. Very often, they aren't contradictions at all. They are timelines.
Oh, like 2025 data versus 2023 data?
Precisely. If your extraction schema failed to capture the publication dates, your synthesis agent has no way to contextualize the difference. Including publication dates in the structured output is absolutely mandatory.
Because it prevents temporal discrepancies from being falsely flagged as data conflicts.
Exactly. Without temporal metadata, an AI will misinterpret the passage of time as a logical error.
That makes so much sense.
Yeah.
Okay, so the extraction works, the synthesis is traceable, the temporal data is aligned. We look at the dashboard and it says we have 97% accuracy. Are we ready for full automation?
No, that is the metric illusion.
The metric illusion.
Taking a highly statistical view here, an aggregate 97% accuracy is a dangerous illusion.
Why? 97% sounds great.
Because it can easily mask an 85% failure rate on a critical narrow field, like claim amount in an insurance document.
Oh, wow. So the model gets the date, the name, and the address right every time, which drags the average up,
Yeah.
but it's bleeding money on the actual payouts.
Exactly. You must use stratified random sampling by document type and field segment to prove stability before full automation.
Stratified random sampling.
Yes. You artificially guarantee your validation set includes a statistically significant volume of every document type, even the rare handwritten receipts, and measure the error rate for critical fields across those strata.
But wait, Claude gives us a confidence score, right?
It does.
So if the AI says it is 0.99 confident, can't we just route that straight through and skip the human review?
Absolutely not. Raw LLM confidence scores are notoriously poorly calibrated out of the box.
Really? So a 0.99 doesn't mean 99% sure?
No. An architect must calibrate these thresholds against a labeled validation set to find out what 0.85 confidence actually means in reality.
How do you do that?
You run thousands of documents where you know the ground truth answers. You track the model's confidence score for every correct and incorrect extraction. You might discover that for your specific invoices, a score of 0.94 actually correlates with a 30% error rate.
Oh, wow. So you have to define what confident means mathematically.
Only after mathematical calibration can you safely route low-confidence extractions to human review. You use human review as a targeted scalpel, prioritizing limited human capacity.
That is fascinating. So to wrap this up for you listening, moving from conversational AI to structured data extraction requires structural guarantees, not just polite prompting.
Exactly.
Tool use, specific feedback loops, and statistical calibration are the actual tools of the trade here. We're strictly following the examguide.md principles.
It's an entirely different paradigm.
Yeah.
But as we lock these models down, I want to leave you with an advanced architectural thought to mull over.
Oh, I like these. Let's hear it.
We heavily constrain the AI with strict schemas, nullables, and enums to prevent hallucinations. But at what point does our bulletproof schema become a blinder?
What do you mean?
Well, say a vendor includes a handwritten note on an invoice saying their bank routing details have changed. But your strict JSON schema only extracts line items and totals.
Oh no, the AI will just ignore the critical warning because there's no JSON field for it.
Exactly. How do we design data architectures that guarantee mathematical safety but still allow the AI to alert us to novel, vital information that simply didn't fit into the JSON schema we designed yesterday?
Finding that balance is the next great challenge.
Yeah.
Until then, keep your schema strict, calibrate your confidence scores, and rely on the exam guide. We will catch you on the next deep dive.